I haven't done that yet. Okay, 6.3, we're going to talk about function operations. In other words, if I have two functions, I can add them, subtract them, multiply and divide them just like you do numbers. So if I have my first function, f of x equals 5x. My second function, g of x equals x plus 2. We're going to add f of x plus g of x. Well, it's just like what you would expect it to be. So I'm going to take my f of x is 5x. My g of x is x plus 2. Well, I'm just adding so I can drop my parentheses. And I just get 6x. So f of x plus g of x, just add them and simplify. What you got? Okay. So now subtracting, same deal. F of x is 5x minus, now the parentheses here are important because it's minus everything of g of x. So that means I have to distribute that negative, and I get 5x minus x minus 2, or 4x minus 2. Okay? So this part of it's pretty simple, straightforward. Now, let's see, I don't want to get too far up here. I want to multiply f of x times g of x. Same kind of deal. F of x times g of x. So f of x is 5x. Times g of x, which is x plus 2. Okay, if I'm multiplying a 5x times x plus 2, what do I have to do? Distribute. So I have 5x squared plus 10x. And that is f of x times g of x. Okay, I could divide them. F of x divided by g of x. I have 5x divided by x plus 2. Can I simplify that?
You sure cannot.
I cannot. Careful, for those of you who looked at that and said, oh, cancel the x's. Don't do that. If it helps, put that bottom in parentheses. That is a factor. In order to cancel it, there has to be a factor of x plus 2 on the top. Okay, so it has to be times something in order to cancel it. So if there's nothing there's no common factors there, you're just done. That's all you can do with it. Okay, questions about adding, subtracting, multiplying, dividing functions? Okay.
Wait, what was the final answer for the dividing?
5x over x plus 2. That's
Okay.
it. You're done. Now, the last type of problem that I'm going to show you is called composite function. F of g of x. Now this is something, it's using information, it's using stuff you already know. G of x is that function, where did it go? X plus 2. So I'm just going to replace g of x with x plus 2. So this is f of x plus 2. Okay, so what I'm going to do, I'm going to look here. Here's x plus 2. I'm going to rewrite f of x so we can keep it where we can look at it. F of x was 5x. Okay. So this is f of x plus 2. So where there's an x, I'm going to substitute x plus 2. So this is just 5 times x plus 2, because instead of x, I have x plus 2. So that would be 5x plus 2.
Wait. One thing that confused me is you said you replace the x with 5?
No,
So
you replace the x with x plus 2 because it's
Alright.
f of x plus 2. That's what that, remember that notation means.
Oh, when the f is 5?
That, well, f of x is this whole thing.
Okay.
Uh-oh. And so this is 5 times x, but instead of x, I'm going to use x plus 2.
Okay.
That's where that came. Okay?
Okay.
Now that's something kind of new. So any other questions on that? We're going to do a few more examples that involve it. We're going to keep working through. Okay. So h of x times g of x. Now let's look at this one. H of x equals 4x to the 1/2. G of x equals negative 9x to the 1/2. I want you to do the first one here. Then I'll do it, and we'll check to see if we got the same thing. So you try it first. H of x times g of x. Okay, so the first one, we're multiplying. 4 times negative 9 is negative 36. Now this, like bases, x to the 1/2 times x to the 1/2, I add their exponents. 1/2 plus 1/2 is 1. So it's just x to the 1. How many got that one? Good? Good? Not good if you were close. H of x plus g of x. First of all, if you didn't get it, do you see which you need to do differently, or do we need to look at that again? Okay. H of x plus g of x. So that is 4x to the 1/2 plus a negative 9x to the 1/2. So like 4 plus a negative 9 because they're like these like terms. Negative 5x to the 1/2. Okay, everybody get that one? Okay. So let's look at that composite thing we did with the other one. H of g of x. Well, that would be h of negative 9x to the 1/2. Remember, this is going to replace just the x. So I get 4, and then instead of an x, I'm going to write everything inside here. Minus 9x to the 1/2, and that's all raised to the 1/2. So now we just have to simplify it. Now, we have a problem with this. Everybody see what the problem is?
Yeah.
What's the problem? The powers. Here, let's go ahead and simplify this. 4, negative 9 to the 1/2. X to the 1/2 times 1/2 is 1/4. What can you tell me about that right there? Except for it's negative. Do I have a real root of negative 9? No. So this one's not defined.
Not possible.
No definition. Not fine. No define. Not defined. Okay. So let's do some more with those composite functions. We'll try and do the ones that are going to work out. Okay, the first one everybody can do. I have f of x is 4x to the negative 1. G of x is 5x minus 2. Write those both down at the top of your paper. Then we're going to do g of 4. Want everybody to just do that one. You can do that. Show your work, how you substitute it. Get me an answer. get 18 for that number 1, g of 4.
Isn't it 5x minus 2 distributed through 4?
Just no, the 4 just substitutes for the x. That's what that notation is. It just substitutes for the x. That's all that is. Okay? So, when I have f of g of 4, well, I already found g of 4. What is g of 4? 18. All this means is this is f of 18. Well, that means I'm going to substitute 18 for the x. So I have 4 times 18 to the negative 1. Well, what does to the negative 1 tell me to do?
1 over 18.
1 over 18 is the reciprocal. So this will be 4 over 18. Does that simplify?
Yeah.
No.
Nice.
Okay. So, yeah, another one we had to wake up the brain on, remembering what you do with a negative exponent. We do have some of those in your assignment today. This is always the reciprocal. Okay, does everybody follow what we just did there?
Still confused.
On number 1?
You plug in 5x minus 2 for g, right?
G of x is 5x minus 2. Let's just write this right under here. Okay, so g of x is 5x minus 2. So what that means is, in place of x, you're going to put a 4. So in place of the x, I put a 4. Okay, it's not times, which is probably, it's that new notation that we've just kind of touched on a few times. Now we're going to be using it a lot. Okay. Okay. So now we're going to do this all at one shot. G of f of 4. Well, I haven't figured out f of 4 yet. So that's the first thing you do. Always focus on the inside part first. So do the inside first. So I have G of, well, f of 4, that means I'm going to replace the x with a 4. So I have 4 times 4 to the negative 1. Well, 4 to the negative 1 tells me to put it in the denominator, right? So this is G of 4 over 4, or just G of 1. So now I move to my second function. G of 1 is going to be replacing the x with a 1.
Which is 5.
So 5 times 1 minus 2 is 5 minus 2. So then it's going to be 3. So keep it in, if you want to, on the side, do this part where you find the f of 4 separately, and then we figured out that was 1. You can do that and then substitute back in if that makes more sense. If it's easier to keep track of it, that's okay. So you evaluate the inside, and then you evaluate the outside, inside to outside. Questions? Okay, let's see if you can do the last one here. F of 4. Back up so you can see what f of x is. Okay, what was f of 4? 1, right? Okay. So basically all we're doing is we're finding f of 1. So I've got 4 times 1 to the negative 1. Well, 1 to the negative 1 is just 4 over 1. So that's, everybody get 4? Okay, last one we're going to do before we move on to this section, from this section, I still have another page here, is f of this is the function f evaluated for 5x minus 2. So everywhere there's an x, I'm going to substitute 5x minus 2. So that's going to go in for that x right there. So the rest is the same. So I've got 4 times x. Well, I'm going to replace that with 5x minus 2. And that's all to the negative 1 power. I can move this up. Hope I did have it down there. So if it's to the negative 1, that means it's a reciprocal. It moves to the denominator, so I have 4 over 5x minus 2. Can I simplify that anymore? No. Okay. So we're going to play with these just a little bit more before we quit. So write down at the top of your page, f of x equals 3x minus 8. G of x equals 2x squared. So I want you to evaluate, and I want you to go ahead and do this. G of f of 5. First thing you're going to do, find f of 5. Do the inside part first. Substitute the 5 in up there. Then you do the outside. So the inside first. Okay, we're going to answer on that first one. Let's try it. F of 5 is going to be 3 times 5 minus 8. So that's going to be 7. So we get G of 7. And then we substitute into our G function. So I get 2 times 7 squared. 7 squared is 49. Times 2, you get 98. We get 98? Yeah? Yes? Okay. Okay. Let's look at the next one. Go ahead and do these so we can get rolling here. So this is
G and you plug 5 in for G.
Plug 5 into the G function. So 2 times 5 squared. So 5 squared is 25. Times 2 is 50. So this is going to be f evaluated at 50.
Or F is plug in 3x minus 8.
Right. So 3 times 50.
Oh, then you plug in 50 for your X.
Yeah, you plug in 50 for your x. So 3 times 50 minus 8 is 150 minus 8, which is 1, 2. Okay, starting to make sense? There's some tricky ones today. Okay, f of 5 we set up here was 7 earlier, right? So this is going to be f of 7. So that's going to be 3 times 7 minus 8. 21 minus 8. 13. And then the trickiest one, always this last one is the tricky one. So I've got f of g of x. So f of the g of x is 2x squared. And then in the f function, I'm going to replace the x with 2x squared. So I have 3 times 2x squared minus 8. Just substitute directly. And then you simplify your remaining answer. So I've got 6x squared minus 8. That's an x, believe it or not. does kind of. Right there by the trees?
Yeah.
Okay, that's all our notes for today.
It's-